In this video, we're going to be talking about the concepts in Chapter 4, which is titled The Mole and Chemical Reactions. We are going to start our chapter by discussing chemical equations. Chemical equations are going to be how we write chemical changes. To remind you of the definition, a chemical change is going to occur when a substance or multiple substances are converted into one or more substances with different chemical formulas and different properties. In order to detect that a chemical change has occurred, on the right side of the slide, we have indicators of chemical changes, which include a change in color, the formation of a solid, in other words, a precipitate, bubbling because one of the resulting molecules is a gas, emission of light, or even emission, as you can see in the image, or absorption of heat. When we have a chemical equation, because this is an illustration for a chemical change, there are parts to it. The substances that will react are called reactants, and we can see that we can have one or multiple. Then an arrow is utilized as an indicator that a reaction has occurred. And when it comes to the result of a reaction, we call those products. You can have one or you can have multiple. And I'm going to include that those will be separated by a plus. In addition to using a plus sign to separate either reactants or products, there's other important symbols that can be incorporated into chemical equations. I already explained how the plus sign is going to separate two or more chemical formulas. We also can use the arrow to illustrate how the reactants produce products. Similar to what we have here, a triangle can be utilized to show that reactants are heated. And next to the chemical formulas, in the bottom right corner, right after subscripts, if present in the chemical formula, we can incorporate the state of matter. In parentheses, if you put the letter S, that means solid. If you put the letter L, that is liquid. If you put the G letter, that is gas. And then if you put the letters A, Q, that means aqueous. Aqueous just means a water solution. When it comes to chemical equations, they can be expressed in words. Please make sure that you go over the worksheet where there's many examples of chemical equations given in words. As we can see here in the slide, we have the following reaction. Molecular hydrogen plus molecular oxygen produces water. When we are doing chemical reactions and we are writing them in the form of chemical equations, let's remember that we must always remind ourselves of the elements that are diatomics. Molecular hydrogen is expressed as H2. Molecular oxygen is expressed as O2. And the chemical formula for water is H2O. You can observe that the state of matter for the different substances is given. So if the word molecular or you see hydrogen gas, that both expresses hydrogen as H2. I'm going to remind you that the list of elements that are diatomics are the following. And the diatomics just means that next to the symbol for the element, there is a 2. The diatomic elements are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Out of all of these elements, the first 5 are found as gases at room temperature. Bromine tends to be a liquid at room temperature. And lastly, iodine is a solid at room temperature. So keep this in mind when you see reactions written in words. One of the other things that you can notice in this chemical equation is that there's these large digits in front of the whole chemical formula. Those are called coefficients. They are necessary in order for us to keep track of the number of atoms, which in a chemical reaction, we must have the same number of atoms in the reactants and in the products. That is because in chemical reaction, we must respect the law of conservation of matter, which states that atoms are neither destroyed or created in chemical reaction. So the named number of atoms we need to have both in the reactants and in the products. Let me illustrate why this is. In the chemical reaction that we have here, where molecular hydrogen and molecular oxygen produce water, if I look at specifically the number of atoms that I have for hydrogen and oxygen in both the reactant and the products, if this equation is balanced, we should have the same number. As you can see, I'm going to create a table in which I'm going to write the number of atoms of hydrogen and oxygen that I have in the reactants versus the products. If I look at the number of atoms in the reactants, since I have a 2 in front of H2, I will multiply this large digit to the subscript. So that means that in the reactant, I have 4 atoms of hydrogen. In oxygen, we don't see a large digit, but there is one that it is implied. So when you don't see a digit, that means that there's a value of 1. So when I multiply that 1 by the subscript of 2, that means in the reactant, I have specifically 2 atoms of oxygen. Then in the product, I go through the same process. This large digit of 2 gets multiplied by the subscript. So in the product, I also have 4 atoms of hydrogen. And when I take this 2 and multiply it by the oxygen subscript, which is 1, even though it's not written, it is implied, I see that there's 2 atoms of oxygen. We can see that this written equation is balanced, so it respects the law of conservation of matter. All chemical equations must be balanced when you work with them. Now, how do we write a balanced chemical equation? These steps are just guidelines that will help you when you are doing problems in balancing equations. Number 1, start by listing the elements on the left and the right hand side of the equation, meaning the reactant or reactants and the products. Then you're going to count the number of each element on the left and on the right side, meaning reactants and products of the equation. You can only balance equations by adding a large number in front of compound or elements. As you observed in the previous example, coefficients are added in front of the whole chemical formula for compounds or atoms. When adding numbers, start with the lowest possible number first, meaning you start at 2, then 3, then 4. Because one of the things about writing balancing equations is that it is trial and error. At times, we may aim to keep even numbers, even though sometimes we must not just focus so much on step 5 because there could be coefficients that are not even numbers. But many times that's basically just our starting point. Then we're going to add the numbers to individual elements last. That means that when you have a chemical reaction, the last thing that get balanced are individual atoms. The main thing that we must remember when writing balancing equations is that we never change the subscripts. Only coefficients are utilized to balance chemical equations. Let's look at a couple of examples. In the following practice problems, first we are going to see if the equations given are balanced. You can do a table in order to understand the number of atoms that you have, or if you want to do the count, as I'm going to show you right now, that is also one way to see it. So for example, I'm going to do letter A, letter B, and letter C in the first problem, which the instructions read, determine whether each of the following chemical reactions or chemical equations is balanced or not balanced. So when I look at letter A, I have phosphorus and chlorine in the reactant, and I have the same atoms, phosphorus and chlorine, in the product. So when I look at this, in the reactants, I have 1 phosphorus, chlorine, I have 3 here and 2 here. That means that I have a total of 5. When I look at the product, I see that I have 1 phosphorus and 5 chlorines. As you can see, this is a balanced equation because we have the same number of atoms on both sides, meaning the reactants in the product. Let's look at letter B. In letter B, my reactants are going to have carbon, oxygen, and hydrogen. Those same atoms need to be in the product: carbon, oxygen, and hydrogen. In the reactants, I can see that I have 1 carbon, 1 oxygen, and I have 2 times 2, 4 hydrogens. When I look at the product, I have 1 carbon, 4 hydrogens, and 1 oxygen. That means that that second chemical equation is also balanced. I'm going to now move on to letter C. In letter C, I have, for the reactants, potassium, chlorine, and oxygen, and those same atoms are in the product: potassium, chlorine, and oxygen. In the reactants, since I have a coefficient of 2 in front of KClO3, that means that 2 is going to multiply by the 1 that is next to potassium. So I have in the reactant 2 potassiums, Same thing with chlorine. Chlorine has a subscript of 1 times 2. That means that there are 2 chlorines. And since oxygen already has a subscript of 3, it's going to be multiplied by the 2. So 2 times 3 is going to be 6 oxygens. When I look specifically at the product, the 2 in front of a KCl means that I have 2 potassiums and 2 chlorines. Next, since I have O2 and there is no digit here, I know that there's a digit of 1. So in the product, I only have 2 oxygens. So when I look at my count, because potassium is balanced, chlorine is balanced, but oxygen specifically doesn't have the same number, that means that the chemical equation on letter C is not balanced. If we're actually given a chemical equation and we need to balance it, similar to what the instructions say in the second problem, what we most do, and I'm going to do as an example, letter A, is create a table in which we write down what do we have to start with. So for letter A, I have nitrogen and I have oxygen, and I need to find out what I have in the reactants, and that's just my shorthand for reactants, versus what I have in the product, and that's my shorthand for product. So in the reactant, I see that I have 2 nitrogens and 2 oxygens. So I have 2 nitrogens and 2 oxygens. In this chemical reaction, I have specifically 1 nitrogen and 1 oxygen in the product. So at this time, the reaction is not balanced. In order to balance it, I have to increase the number of atoms in the product specifically. And the only thing that I can use is going to be coefficients. So in order for me to balance this reaction, I need to add to the chemical equation a digit of 2 in front of NO. And when that happens, that digit of 2 will increase the nitrogens by 2, because you will be multiplying the coefficient by the subscript of 1 next to the nitrogen. So that means that now I have 2 nitrogens, but because coefficient affect all of the atoms within a chemical formula, then that means that this digit of 2 also gets multiplied by the subscript of 1 in oxygen. So I have also 2 oxygens. Now that I place a coefficient of 2 in front of an O, my equation is balanced. Since no digits needed to be added in front of N2 and O2, remember that there is a number. In that value, even though it's not written, I'm going to write it now, is a value of 1. It's just that coefficients that are a value of 1 tend to not be written. Another important thing and skill when it comes to this is word problems, meaning a reaction is given to you and you need to write the balanced chemical equation. In this practice problem, it reads, nitrogen dioxide is an air pollutant that is produced when in part nitric oxide reacts with oxygen gas. Write a balance equation for the production of NO2. So in order to write this chemical equation, we need to detect what are the reactants. according to the words, this chemical equation needs to be written to express that nitric oxide, which is NO, will react with O2 and is going to produce NO2. Then we have to look at what is the number of atoms that I have specifically for each one of the elements that are present in my chemical equation. So if I make the list, I have nitrogen and I have oxygen as my only atoms or elements in my chemical reaction. I'm going to next write what is the number of each in the reactants versus the products. When I look at the number of nitrogens in the reactants, I only have one. When it looks at the number of oxygens, I have one here and I have two here. So there are 3 oxygens in the reactants. When I look at the product, I have also one for the nitrogen. And when it comes to the oxygen, I have 2 of them. So understand that whenever we make changes in order to start balancing, we, for the most part, try to make results that are even. It's not necessarily that the coefficients are even, because we can have coefficients of different digits. Since I can see in my atom count that the nitrogen is balanced, the only thing that is not balanced is going to be my oxygens. So as a strategy, one of the things that we can implement is that since I know that I need specifically to increase the number of oxygens, I can actually say, well, let me start by writing a digit specifically in front of the NO2 to increase the number of oxygens because I have less of them in the product. If I put a digit of 2 in front of NO2 to increase the amount of oxygen, then that means that by putting the coefficient of 2, my nitrogens go to 2 and my oxygens go to 4. Because remember that this digit of 2 gets multiplied by the digit of 1 in the nitrogen, but also by the digit of 2 in the oxygen. And even though at first you'd be like, well, you made it more unbalanced. Well, one of the things is that now I'm going to try to balance the nitrogens. So if I also put a digit of 2 in front of nitric oxide, in other words, NO, then what I can do is now take this digit of 2, multiply it by the 1 that is right here next to the nitrogen. So by doing this, now I have 2 atoms of nitrogen, so I rebalance my nitrogens. And next, if I take this digit of 2, multiply it by the digit of 1, that is the subscript of oxygen in NO, I've increased the number of oxygens to 2. When I add 2 to the O2 that is already in the reactants, then that means that the oxygen will go to 4. And now we can see that this chemical equation is balanced because we have 2 nitrogens on both sides and 2 oxygens in both sides. Since we didn't place a coefficient in front of O2, understand that there is one, and it's going to be a coefficient of 1. Make sure that you practice how to balance chemical equations.